Hi everybody, I hope you're doing fine. I am. So, I'm here to talk to you about a project that we've been thinking about for a little while at Inverse, where I work. And it's called Fingerbank, so it's DHCP Fingerprint database. Come on. My friends are making fun of me, so yeah, that's pretty funny. Assholes. So, so I'm here to talk about that, and let's see how it goes. Today I'm going to first do reminders about device fingerprinting, passive fingerprinting, DHCP fingerprinting. I'm going to cover some defensive and offensive use cases. Then announce, quote unquote, Fingerbank, and talk about what's next and what are we are interested into doing in the future. So who I am is I'm Olivier Bailado, I guess would be a close English equivalent. I'm working on Packet Fence since 2009 as a lead developer there. I'm also teaching InfoSec in Montreal to undergraduates, having a lot of fun doing that. I'm really an open source guy, so really into Android and Linux and stuff. I'm a new father. I brought my kid here, which is an odd choice in Vegas. It's really not that great actually, because she's crying all the time. She's 7 months old, so well, I wanted my family here, so here they are. This talk is implementing the UDrink protocol. So if I say something obviously stupid, you can interrupt me and I'll offer you a beer if you are smarter than me. So let's say it that way. And also during the Q&A, I'll have beer for good questions. So here we go. So device fingerprinting, what it does is that it identifies pieces of your software or hardware. You're probably familiar with PUF and stuff like that. So there are various types of it: operating systems, devices, browser, web server, web application. It's another type of signature, more or less, if you want. So as easy as that. You know what? Okay. So two approaches of gathering fingerprints. There's an active approach and a passive one. So the active is that you are doing stuff. So it can be detected. It's more intrusive by nature because it's active, as opposed to the passive technique, which you only listen on the LAN or on a router in between the network. So it's really clear, active, passive, and what it means. So I guess I won't focus on that. But it's really completely separated, like the two techniques. And some tools, well, most tools are focused on one approach, but there are new tools that are doing both. So SynFP is one of them. You can now feed it a PCAP, and it will do kind of a passive approach if you want. So why passive? Well, not why, but reminder on passive fingerprinting. So networks are really noisy. You probably already know that. You open up a TCP dump everywhere you get, and there's a lot of stuff going on, and a lot is about broadcast, and you get all the broadcast traffic. Sometimes also you are in between, so you are the gateway, or you have a mirror port, and so you see all the stuff that's going on. The wall of sheep is a good example of that. So if you can sit at a spot like that and sniff traffic, then you will see a lot of stuff. And fingerprinting becomes really interesting because you'll be able to identify operating systems of your guests, the browsers, the version of software and stuff like that. So on the LAN, there is DHCP, which is a broadcast protocol that you can use for fingerprinting. Talking about that in the next slide. There is the multicast DNS, the iTunes, all that stuff is very verbose, noisy, and helps you a lot of identifying software or hardware that you're using. On the WAN, honeypot is kind of You know, you could do fingerprinting with a honeypot, and you'll see kind of the internet noise if you want. So it's possible to do that on the WAN also, passively, of course. So DHCP fingerprinting, the meat of the matter. Okay, so DHCP is a great network. It helps you, you know, be online easily, low maintenance and stuff. So it's broadcast based, and it's on every LAN segment, so every VLAN if you want. And like through time, we found a way to, people found a way to aggregate DHCP, for instance, with IP helpers, sometimes called UDP helpers. So you don't have a DHCP server on every physical segment, which would mean a lot of costs. So because of that, you have you use IP helpers, so your DHCP traffic is all aggregated upstream to a few servers, and this is kind of a nice feature because, you know, all the information about what's going on IP-based is aggregated because of the IP helpers. So DHCP fingerprint, because of that, are easy to collect and rarely spoofed. So rarely spoofed, by that I mean if you are, let's say, a pen tester and you want to expose yourself as a voice over IP phone, for instance, well, not a lot of people know that and know how to do that. So it's really, really rarely spoofed. And by that I mean I looked to do it, and the only way I found no tools, no automated tools to do to spoof DHCP fingerprints. And the only way I found to do it was modifying the DH client configuration directly on Linux. So it's seriously, for now, pretty reliable. In the future, probably there will be tools, or people will kind of have a backtrack, mimic a Windows XP system. But right now, you can spot backtrack as a Ubuntu system with fingerprints. So the fingerprinting, again, a reminder, what is possible to fingerprint on DHCP? Well, it's, you could focus on the retransmission timing and all the timing stuff. On the TTL, so at IP TTL on the packets, sorry. But the greatest, well, what we've been using for packet fence actually is the option 55, which is the parameters. So DHCP is kind of a key value thing. You have, you request a list of options, and then the server sends you the values in it. And there's the two-way of the game. So the client and the server have this, you know, option and then parameter. And so option 55 is actually really, really interesting because it's all the stuff that we use DHCP for, and a lot of options that we don't use, but they are still there. So there's an example on the next slide, but I mean, host name, domain name, and stuff like that is all in there. So if you want more details on DHCP, there was a Black Hat Japan presentation which I built on for the Fingerbank project that you can check. It's Eric Coleman and David Laporte who presented, and it's actually really nice, really detailed into the topic. So here are the option 55 list. So we only focused on these. So and with this option 55 only, so no other parameters, we have a database of 160 different OSs and devices, and it's kind of all blurry together nowadays, OS device and stuff like that. So I say /OS/devices, and this includes a lot of stuff, like scary stuff. I mean, you got the fluke devices, you've got switches, and now when I saw that, I'm asking myself, who the hell run DHCP on switches? You know, it's shouldn't all be fixed IPs, but anyway, we got them. We have a lot of it, and so the option 55, it's simply a list of the option, as you can probably see on the slide. It is like 1, 15, 3, 6, 44, and it's all because of the client, what they requested. only that simple list helps us to uniquely identify a lot of stuff. And like UPS devices, there's Pixie stuff, thin clients, it's really like gaming consoles, smartphones, and we can spot Android between each other. So we have like the HTC Android, the Samsung Android, and so it's great, seriously. I was amazed by that, and that's the reason why we're presenting or proposing Fingerbank, I guess, is that like it's on every LAN, everyone has it, everyone like has this resource that they can, you know, identify what's going on in the network, but no one was really, you know, pushing it, or maybe it was all in proprietary stuff, and I don't use proprietary software, so I just don't know about it, but this is the big reason. So let's get into some use cases. Of course, I guess I am into more defensive stuff, but here we go. There's you can do really easily LAN operating system inventory, or even, you know, flagging people with Windows 95 and telling them, hey, come on, get you know, something serious, please. So here is a screenshot of what we do with packet fence. You see the last switch, last port, last VLAN. This is possible with DHCP option 82, which is implemented in Cisco switches. It's more or less reliable, but still it can help you. So it's kind of powerful to have the two of them blended in, because you will know for a host where it's located, and because of the Fingerbank technology, if I may call it like that, know what OS it's running. So it's pretty powerful and interesting for network operators to know that. You can do firewall and network access control integration to blacklist end-of-life stuff, for example, or even better, backtrack, or Linux if you want. So this is also pretty powerful, and we use that in packet fence a lot to, you know, and this is like sliding to the next point, but we do that to automatically register voice over IP devices, so that or printers, so that the users don't have to do it themselves, which is, I know, a security problem, because we're relying on client-side stuff to actually behave on the network. But I mean, it's a usability problem, you know, someone has a choice to make. But so if you are a pen tester, then definitely, I mean, add in your toolkit, I would say, spoofing your DHCP option 55 list, because it can make the network part of the infrastructure behave differently based on what you are. So offensive use cases, obviously stealth LAN recon, so you can like sit there, hook a device, and then just sniff the traffic and see what's there. And I mean, it's even better when you get Windows 98 popping up and saying, hey, I'm Windows 98 and I want an IP address. So now, I mean, you only have to own it like Metasploit, and boom, it's done. So the clients, they come to you actually in that case, you know, instead of you having to nmap the network and stuff. So this is, you know, it's a big one, it's really interesting, but afterwards I was trying to find other use cases, offensive use cases, and actually, I guess someone will have to come up in the Q&A room and tell me other offensive use cases. I failed at that. So why did we decide to push Fingerbank? Because you saw it. It's so simple, this stuff. It's only a list of option numbers separated by commas, but I hate information hidden in silos, and we need to be together if you want to spot devices. We get a lot of fingerprints, and we just can't cope with the flow, and they are all anonymous, so we can't, you know, ask back. Or even if we do ask back, let's say we have the opportunity to ask back, people don't really know, you know. They run the software, it listens to everything, and they don't even know the device that are broadcasting on their network. So the project's goal is really about sharing it, talking about it, getting this out. And so this is why we're launching the website and the mailing list. Yeah, so raise awareness and stuff like that. So what is it actually? It's pretty simple. We popped open a website and we decided to just output the signatures and the documentation and the mailing list. We're probably going to open an IRC channel too, but it's really links to the existing signature, and we just packaged it in a nice format. And then based on the feedback of the community, I mean, there's a lot of stuff we could do with DHCP fingerprinting, and based on who's interested, and we're anticipating pickup by the larger network vendors, hopefully. And so with that, there will be definitely like more offensive tools focus on that, defensive tools too, and reporting and stuff. So we'll see how it goes. So for now, who's backing it? The guy who wrote the paper, Eric Coleman, wrote the DHCP fingerprint paper that was presented at Black Hat Japan. He's also started to write another one on DHCP version 6. So it's interesting. I haven't read that yet, but he's really into it and a lot into passive fingerprinting. David Laporte was PacketFen's original founder. I think he's working at Harvard as on their network. And ourselves, Inverse, who's sponsoring time and servers and stuff. Not that much resources, but still, they're still paying me to do it, which is great. So they're backing it. So what's the future of Fingerbank? Well, again, we need maybe probably better tool to share, because a lot of them actually are close to each other when you look at the fingerprints. And so we would really need better tools to find closest match and stuff like that. Also, right now the data formats, PacketFence uses stupid INI file format type, and Satori, which is Eric Coleman's tool, is using XML. So we want to consolidate the formats, and so have better reuse over with that. And then we want, and this is the main focus, is we really want a lot of mind share around the fingerprints. And so that when we get new obscure fingerprints, that actually someone who will be subscribed will know about it and will be able to say, oh, hey, this is Intel when it's in a BIOS boot mode. It's actually doing DHCP and sending that. So there's a lot of the obscure fingerprints that we'll need help on. That's pretty much it, and I hope you enjoyed, and we'll see you in the debriefing room if you're into fingerprinting, I guess. Thank you.